Okay, so what's the elevator pitch here? I think the best way to understand any piece of software is to go and read the source code. And to understand it even better, try to make some changes to it and see if you were able to successfully make the system do what you wanted it to do. If you can successfully do that, means you do understand the software. So I'll be going over different repositories which either have their code open or open source. So I will read the code. If it's an application, then build it locally, compile it, run it. If it's a library, then use it in something and try to make it do something. So I will cover mostly Go related topics or things related to networking because that's what my interests are mainly in, and I'm good with Go. With other languages, I can read the code really good, but I'm not really good in other languages. So I'll be targeting mostly source codes that are Go related, or if it falls into the area of networking, but I'll also go over other source codes like Envoy, which is in C++, Nginx, OpenResty, which is in C, because these are network libraries. And because I'm interested in the networking part, so I will understand logic. So basically any software is two things, right? The language and the logic. I have to either know or be interested in one of those things in order to deep dive into the thing. Basically, there has to be either the language that I'm comfortable in or the technology that I'm comfortable in. And I really like networking, so that's what it is. So this first series that I will do, I will go over client-go source code, which is a client library for interacting with Kubernetes API server. So basically it helps you to interact with Kubernetes API server without raw dogging it, which basically means that you do not have to create your own HTTP client and manage all the get, put and post requests and manage all the schemas and do all that underlying networking thing. It abstracts all the networking part, provides you with good abstraction that you can work with without having to worry about underlying networking part. If you Google real quick, the first thing that you might find is that Kubernetes is a container orchestration platform. But for all practical purposes, I want you to think of Kubernetes API server as a really good API server backed by a database known as etcd. Container orchestration is just a use case for this API server. It can do a lot more than that. Kubernetes API server itself doesn't do pod orchestration. It just facilitates it by being a really good API server. Okay, so let me give you an analogy. Okay, let's say you had a Node.js server running and it is connected to a database like MongoDB, and clients performed CRUD operations on resources like students, teachers, classes. Then it will be a classroom management system. If the resources were clothes and perfume, then it will be a shopping management system. So in an abstract categorical sense, you just have an API server, but functionally it can become XYZ management system based on the resources. So similarly, on an abstract categorical sense, Kube API server is just an API server. But when one of the resources is pod and when one of the clients subscribe to these resources actually reacts by scheduling those pods on specific nodes, and some other client somewhere notices that change in resource and starts running the pods on the node, then in concrete sense, you have container orchestration platform. So that's it. Container orchestration is just a use case that can be built using this CRUD API. And if you want to see these API requests on these resources, just add the verbose flag when you're using kubectl to see what are the requests that was sent under the hood. So kubectl is just one of the clients. Kubectl apply internally creates a resource. So you can look at the source code for this and you will find that it is actually using client-go. Actually, it's not using client-go directly. It's using CLI runtime package, which is provided by Kubernetes, which provides you with a basic scaffolding if you want to write a CLI for Kubernetes. While kubectl is a client that will create a resource, there is another client which is watching for resource and will react by doing something. Now that's a controller. Now when that resource being watched is a pod and the controller is kubescheduler and kubelet, yeah, we get the container orchestration. And that is why controllers are really important, because all the functionalities are really supplied by these controllers, which are just reacting to resources that are being modified and changed and created, and all sorts of things are happening to these resources, which is being facilitated by the Kube API server. Concrete behavior of the overall system is determined by these controllers. So functionally, it's just a reconciliation loop with a whole bunch of clients driving the state of the system. Okay, so enough jibber jabber. Now I will dive into the source code. And in this first part of client-go, I'll go over two packages, /Kubernetes and /rest. Since the library doesn't have a main function, you don't have a starting entry point to the source code, but usually such libraries provide the methods, functions, and structs that are exported in either usage.md or readme. Even better, in client-go, we have an examples directory. Oh, nice. Let's start from there. Okay, so the first example here goes over how to create a deployment and then update a deployment and then list a deployment and delete deployment. So basically performing CRUD on the deployment resource. Okay, so the first thing we can see is that in order to create a deployment, create was called on the instance of deployments client. Deployments client, which was created out of this particular client set. So on client set, we have all sorts of methods, one of which is apps v1, which is the group of this particular resource. So in a Kubernetes YAML that you might write, in API version, you provide the group. So that this is that group, app/v1. So you first call on the group, and inside of groups, you have these resources. So if I just do client set dot, I can see all the groups that are available here. And if I, let's say, pick any one of the group, let's say I pick events v1, and then I dot again on this, all the resources that lie under this particular group are available here. So that is just events in this case. And in my current case, I have the apps v1 group, and within which we have the deployments resource. Let's just click on apps v1 and see where it takes us. Okay, so we are in client-set.go in Kubernetes package. Here you can see client-set is actually a struct which implements all of these methods, and these method names are basically the groups. Since there is a struct implementing all of these particular methods, if I just scroll a little upwards, I'll find finally the interface. So in Kubernetes package, you have an interface which provides all the methods that are to be implemented if you want to call yourself a client set. And client set is the struct which implements all these interfaces. Now, one thing you might notice is that the interface is actually composed of all of these interfaces, and each of these interfaces correspond to a particular group. So the apps v1 that we just accessed, apps v1 method correspond to the apps v1 interface. And subsequently, you might notice that in client set is composed of all these smaller structs, and each of these individual structs implement. So for example, you have the apps v1 struct over here, and this apps v1 client, this implements the apps v1 interface. Okay, so let me draw this out. So you have an interface which is composed of all these interfaces, and then you have a client set struct which is composed of all these smaller structs implementing each of these interfaces. So interfaces are dotted boxes and structs are non-dotted. Structs inside interfaces represent those structs implementing the interface internally. So the way I like to think is to think interfaces as the outer black box with a pluggable engine, and concrete structs are those pluggable engines responsible for implementing the functionality. Okay, so by now you might understand one thing, that all the Kubernetes resources are grouped by the groups. And if you want to see all of the groups that are available and all of the kinds and everything, you can just do kubectl API resources. And here you can see that you'll get all the kinds, all the names of resources basically against their. I'll explain what this kind is and what's the difference between kind and name, but essentially you'll get all the groups listed over here. And so for example, the flow schema is a name of the resource, and this resource belongs to the group flow control API server.k8s.io v1 beta 1. So if I'll go in my interface, I'll find something by the name flow control, and inside of that I will find something by the name flow schemas. Let's see. Okay, so this is like the flow control v1 interface over here. So if I click on this, I will find all the resources that are being grouped under this particular resource. So if I go into flow schema getter, you can see flow schemas. So it just only supplies one resource, which is flow schemas. So you get the point, right? Okay, so now we know that client set actually implements an interface which operates over each of these individual groups. And if we go inside of any of these groups further are composed of specific interfaces that correspond to specific resources which come under these particular groups. So for example, apps v1 is further composed of daemon setter getter, deployments getter, replica set getter, stateful set getter. So all the resources that come under apps v1 interface themselves are an interface. And if you go into any of these particular interfaces, these are nothing but the CRUD operations on that particular resource. So for example, the replica set interface is basically just create, update, delete, and performing CRUD operations on the replica set resource, which is replica set struct is, you all know what it is. It's just a Go struct corresponding to the replica set YAML that you're aware of. So far, so good. Okay, let me also draw this out first. Okay, so one thing you will notice is that all of these interfaces at group level have a method called REST client in all the groups, which basically returns a REST.interface. And this REST.interface is also present in all the structs that implement these interfaces. And then this REST.interface is then passed on to the underlying structs which implement each of these methods. So inside the daemon set struct, you will also find the REST.interface. So what is this REST.interface? Let's click on it. Okay, so now we are in the REST package. And in REST, you have the interface captures the set of operations for generically interacting with Kubernetes REST APIs. So all the methods that you see over here, like create, update, delete, all these methods inside of each of these resources are actually implemented using the rest.interface, because this actually performs the CRUD operations, the post, put, patch, and get. So for example, if I look at daemon set struct, it has the rest.interface, right? And if I go and look at the get that it does, it internally actually calls the client.get. So client is basically rest.interface. So the rest interface that is defined over here has these methods verb, post, put, patch, get, delete in API version. And then these methods are being used by each of these structs, which are implementing interfaces for each of these resources like daemon set. So if you want to do get, list, watch on the daemon set resource, the way daemon set struct is implementing it internally is by using this particular client, which is rest.interface. And rest.interface provides you with the methods like watch, and you can provide it the resource and the namespace that you want to. You can basically in a builder pattern build up this particular. So for example, versioned params. I will go over what this particular rest.request is in a while, but yeah, the gist is that you can do a watch, and you can perform get and post and patch and all of these HTTP verbs. And these verbs are actually defined inside of rest.interface. And here is the REST client. So this REST client struct is actually what is being returned everywhere that you see over here. So if I go just a little bit over here. So when you will call REST client on this particular apps v1 interface, so you will call apps v1 client, and inside of apps v1 client, you will call the REST client. And when you will call REST client, the implementation of REST interface that will be passed, the default implementation is this one. You can override this with your own implementation, but this is the default implementation. Most consumers should use client.new to get Kubernetes API client. So using client.new, you don't manually, basically it is not advised that you manually fill this struct. You will call client.new and you will get this particular REST client filled up with all the URL of the API server and everything. So this REST client is what implements all of these HTTP verbs. Let's find out where that is. Okay, so when you call post, put, patch, get, all these CRUD methods on this particular REST client, it has a generic function which is verb, and the verb function takes the type of request that you're trying to make. So for example, here it is post. So if I click on verb, I will find that internally it creates a new request. So now we're getting to the request struct. It creates a new request by passing the client, and this client has all the URL and everything. So the HTTP client will be actually created over here using the new request. And when you have the request struct, and this will basically return the request struct, we are going to what this request struct is. And on the request struct, you can call the verb method. Let's go into the verb method. So verb method takes the verb and it sets the verb on the particular request. And now let's finally go to the request struct. So request struct has the REST client. And if I just scroll a little downwards, I'll find that. So you can see that all the methods here that are implemented by the request struct return a request struct. So it's kind of a builder pattern where you can call verb and then it returns a request, and then you can again call prefix. So kind of you can keep building a particular request. What it means by building the request is the URL that you see over here, like API, v1, namespace, default pods. This is iteratively being created by calling methods on the request struct. So when you call request.namespace and provide default, then this will be appended on the URI. And then you add the resource name, which is pod, then pods will be added here. Okay, so this is the function transform response implemented by the request struct, which finally returns back the result struct, and result contains the result. So let me see where the transform method is being called. So if I'll click on this to find the references, it's being called over here. So this do method, let's go to the do method. Okay, so finally the actual request is made when you call do. So do formats and executes the request. It returns a result object for early response processing. So this is the do method. So this request method is actually what creates that particular HTTP request and gets us back the request and response. And when we have the request and response, we provide it to transform response, which is responsible for picking up on these particular request and response instances and returning back the result. And this result contains the body of the response, the content type, the status code, and the decoder. So what this decoder is basically, okay, so this decoder is actually inside of API machinery. So yeah. it's an API machinery. So you have different types of decoders depending upon what was the type of your response was. So it can be serialized in JSON format or YAML format or maybe protobufs. So depending upon the response that came back from API server, different decoders will implement this particular decode method. So right now I'll not go into the decode method, we'll come back to it, especially when we'll be talking about the API machinery package. So right now we can have the idea that this result struct is being returned by the transform response method by taking the request and response and constructing this particular struct, which then will be used by us to do some productive stuff. And what is that productive stuff? You can take a result instance and then get things from it. Get things like a runtime.object. So this runtime.object, this is the Kubernetes object. So a deployment or a pod or a resource, anything. So when you will call get on result, you will finally get the runtime.object. And here is where the deserialization is actually taking place. So get returns the result as an object, which means it passes through the decoder. So the decoder that may be implemented for this particular type of response that the Kubernetes API server gave. So maybe it's a JSON. So you can call the decode method on that particular type of decoder. So the decoder is actually inside of the result. So when you construct a result type, you have the decoder over here. Okay, so result is actually returned by transform response, and here is actually where we create the whole result object, and I can see that the decoder is created over here. So like depending, as I said, depending upon what your content type was, different decoders are present inside of API machinery. Okay, so there is this decoder method that is again in source code. This client negotiator handles turning an HTTP content type into an appropriate encoder. So depending upon whatever your content type was, it will return an encoder, or depending upon what your content type was, it will return a decoder. I will not go into encoders and decoders of different content types, but just know that using these methods provided by the API machinery, you can have methods which return you encoders and decoders depending upon your content type. And using those decoders, you can basically decode a particular request.body, which is just a slice of bytes, into this runtime.object, which actually represents a Kubernetes object. Okay, so to summarize everything that I just said, by now this deployments client has these create and update delete kind of methods, and this is inside this particular deployment interface which has the create, update, delete. And so the same applies for any particular resources. You will have pod, and there you'll also have these create, update, delete, but instead of deployment there will be pods here. And these deployment interface or XYZ interface is basically implemented by deployment struct. In case of pod or anything, it would be pod struct. It basically goes over for any other resource or any other group. I'm just going over deployments, and this deployment struct implements these create, update, deletes by internally using the dot get and the dot post and put and patch and these verbs on the client. And this client is just rest.interface, from where we enter into the rest.interface, and this interface provides the HTTP verbs, and this interface is actually implemented by the REST client. This REST client basically provides you with a generic, you can basically pass in which particular verb for which you want to get a particular request, and this request is what iteratively get, this request is what is built iteratively. And finally, if I go to the do method, where is the do method? Yeah, so on the request, when you finally call the do method, here is where the actual request is made, and you get the request and response back, and you finally call in the transform response, where you finally build this particular result struct, which is built by serializing, which is built by basically decoding this particular slice of bytes using a decoder that is actually created by this particular negotiator dot is basically returned by this negotiator dot decoder method. And in API machinery, you have different decoders and encoders for different types of media type. Depending upon your media type, you get a particular decoder. So for example, for JSON, you'll have some JSON decoder which will decode your particular slice of bytes into this result struct, and this result struct is finally what you get. And then you can call get here, which will finally call the decode on that decoder and will bring you a runtime.object. And this runtime.object is the Kubernetes object that you were looking for. And this runtime.object is what you will get here finally, here when this result and this result and this result is basically, you can see this is apps v1.deployment. This is apps v1.deployment. This is what it finally returned. And this apps v1.deployment, this implements the runtime.object. And this is a Kubernetes object. This is what gets stored in etcd. Okay, Okay, I just hope that whatever I said by now made some fucking sense. Okay. Now, okay, so let's try to use it. I just took the main.go into my own client-go test repository because I want to make some more changes to it. Wanted to clean things up, so that's why. So let's just try to go run main.go this thing. Okay, let's see what happens. So if we do go run main.go, the first thing that will happen is a panic because a demo deployment already fuck. I'll just delete the deployment and I'll start again. Okay, go run main.go, and the first thing that will happen is a deployment is created. So a deployment is created. Let's also cross verify using another client, which is kubectl. So let's, okay, so a demo deployment is created actually. So when you click on return, the deployment will be updated. The replicas are updated here. So there is an update operation that is performed, and then you list all the deployments, and then you delete the deployment. So a simple CRUD is happening over here. Let's make some changes. Okay, so let's start tweaking first. Before I implement my own thing, I'll make some changes to the original source code, like add few logs here and there to see what is happening. So I have this go.mod where I have pinned the client go from k.io to my own local version so that I can make changes to it and test it. And in this particular client go test, I will be calling methods from client go, which is like the local client go version of so let's go to something like create. In create, let's go to the implementation. Let's go to the do where we talked about the actual request is made, and let's go to transform response. Here we already got back the response. Okay, so let's try to print something over here. So we can do something like the request URL and path. We can print that just to see what happens. So request URL path, thanks autopilot. And I can come over here, I can run go run main.go, and now the path should be printed every time that CRUD operation will be created. So the first request went to API apps v1 namespace default deployment. The second one, there were two requests over here. So for update, there were two requests, and then there was another request that went to the same endpoint, and the last one went to the slash. So here you can see this one went to the deployments. So on slash deployments, you performed the post, you created the deployment. When you wanted to update the deployment, a particular resource was fetched. So demo deployment here, listing the deployment, we just called the deployments, and then to delete the deployment, we performed delete on this particular resource, appended it over here. So we can see that the path is being created, right? Now, what to do now? So internally, if it's just CRUD operations that are being performed, and even we don't have to do that, there is a REST client that does that. So we can practically create our own group, and we can create our own resource under that group, and we can just reuse that particular REST client to perform CRUD operations on that. But here's the catch. If we create our own group and then a resource, Kubernetes API server also needs to know what that particular thing is. And that's what we do in controllers, where you kind of create a CRD. A custom resource definition is a way of telling Kubernetes API server, like, this is the schema of my resource. So you register your own custom resource with Kubernetes. We're not going to do that right now, okay? But I still want to create my own group and my own resource. So here's the thing. I cannot do actual CRUD operations on my own group. Like if I create a group name, let's say I create a resource by the name applications, okay? It's my own construct and I have my own YAML for this particular thing, let's say. But let's just say that in client Go, I want to have my own resource on which I can do the list and the create, and I can do all sorts of these things. And internally, the application will just create a service and a deployment. So because there is no application construct that is registered with Kubernetes API server, this is my own made up thing. So what I'll do is that I will create a particular group, and then I'll create my own resource, which is applications. And internally, I'll implement it as such that whenever you create an application, it'll make two create calls, one for the deployment and one for the service. So usually it is done using controllers, and usually the logic is that using something like client go, you will actually perform CRUD on your resource, and then that will go to etcd, and finally when that is stored in etcd, that particular resource, that particular resource is created, that update will be given to all the controllers that are watching for that particular resource, and one of these controllers will have the logic to convert that application construct into the deployment and service. So all that round trip will be happening there. And that is actually the actual good way to do that. This, what the thing is I'm going to do right now, that's not how you implement a controller. That's not like, everything is happening on the client side only. So this can be a use case for someone who wants to add their own resource in client-go, but without changing anything about the Kubernetes API server that they're using. They don't want to create a CRD. They don't even want to write a controller. They just want to have their own client-go, which has internal logic to convert their own custom resource, a custom with a quote unquote, because it's not actually a CRD, into a deployment and a service. Enough jibber jabber. Let's do it. Okay, so let's finally create what we wanted to create, a new group and a new resource. So we can see that inside of Kubernetes typed, we have all these groups, apps, authentication, authorization, and all that. Let's not create a group. You know what? Let's not create a group because it's all too much effort for a whole bunch of nothing. So let's just reuse an existing group. So I'll just reuse apps v1, and inside of apps v1 you can see this is the file where you have the actual interface defined, and then these different daemon set file has the daemon set getter interface, and the deployment file has the deployment getter interface and all that, which means that if I want to have my own new thing like the something like applications getter, let's just call it applications getter. So I need to implement applications getter, right? So just like stateful set is implemented over here, I'll just create my own file. Let's just call it application.go. Okay. Now, so the first thing that I'll do is I'll create the application getter interface. Okay, so now I have the applications getter interface defined over here, and but there is nothing that is implementing this. So let's just change that. Let's also use the apps v1 client to implement the applications getter interface. And this application getter interface is just, we haven't defined the method here. So applications getter interface will, so just like the daemon set getter interface has a daemon set method which takes a namespace and returns the daemon set interface, the application getter interface will have the applications method, which will also take a namespace, and as the autopilot is already suggesting me, will give me back the application interface. So let's implement the application interface. What is the application interface? And this is just a facade. This is a facade, and internally actually we will be calling the create and update on the deployment and service, which we talked about. Okay, so in this applications interface, I'll have a create, and just like all other resources, you have create, update, delete, and all those. I will not go over update, delete, get, and everything. I'll just implement the create over here, and the auto complete from Copilot already suggests us just do this, and it's basically taking the application from v1. So it thinks that there already exists an application named resource, but there is no such thing as application. So I'll just remove this. And here I will create the application struct, the actual application struct. So this is the object. This is the hypothetical Kubernetes object, which doesn't exist. Let's just give it a name for now. Okay. Okay. So now we have an application interface that has the create method, which does it for applications. But internally, remember, the create is not going to call the create for this particular resource to Kubernetes API server, because Kubernetes API server doesn't know about it. So this is going to be a facade over actual creation of deployment and service. So let's do that. Okay, so immediately we get this error that this particular apps v1, which is the actual client, which is the actual struct which was implementing the interface. So it says that it doesn't implement the applications method, which is true. So we have added the method for our resource in the interface, but we also need to add that in the actual implementation, right? So here is where we'll do that. So let me just add that. So again, thanks for giving it to me. I don't have to do anything. GitHub Copilot recommended correctly, which is that it'll take a namespace and will return the application interface. But I haven't written the new applications method, and I'll just write it over here. So func new applications will be, let me wait for the Copilot. So this new applications, I'm implementing the new applications here. It says the unknown field client and namespace. Okay, so I think in applications, it's good to have these two fields. So I can add client, which will just be a REST.interface. Or actually, let's just try to first start with the REST.interface, and then later on, I can also have a namespace, which is string. And I think now I should not get an error. Okay, so now I have this error that I cannot use the application struct because this application struct yet doesn't implement the create method, which is true. I mean, that's the error right now, that you cannot use the, again, we created the application interface and we defined this interface, and this interface we gave it to applications getter, which we gave to the apps v1 group, and but now it wants the create for this application interface. And if we say that this application struct is implementing the application interface, where is the implementation? So let's write the implementation now. Okay, let's just take the boilerplate here. Okay, the moment I apply the boilerplate, the error goes away, but right now it does nothing. It doesn't create anything or anything. So this is where the logic will go. So all the logic will go here. So here's what we're going to do. When there will be a request to create an application, we will convert that to deployment and service resource, and then call create on those. Let's try to do that. Okay, so what I have done here is that I have created a deployment object and a service object. These objects are what eventually will be created, right? So I have a default definition of these objects. And of course, the application struct will bring some configuration options to this. So right now, this service is just a service that exposes port 8080 and looks for pods with selectors app demo, and deployment has a particular nginx image. So a particular deployment and service, your usual application, how an application is deployed. So the logic will be that I will basically populate some fields inside of these deployment and service objects using the, which is over here. Right now we only have name. Let's try to enhance this. So what are the things that I can add here? I can add maybe namespace here. So I can add image name, maybe that you can provide which image you want to run. So right now I've just provided nginx. You can maybe also provide the port that you want to expose on your service. You can also provide the container port that you want to expose, and container port will just be, let's say, uint32. So now how I will get these configurations is, we'll talk about that later. But once we have an application struct which has all these things, then we will use these things to populate our deployment and service. So let's do that. Okay, so there is this into method. So whenever you get the result, you have to provide a object, a Kubernetes object, into which this particular thing will be decoded, as we talk later, right? So here, where we are implementing this, we have the original deployment. This deployment is what we will send to the Kubernetes API server, but the response that comes back, that response has to be decoded in another deployment. So for that, I have created this empty result deployment object in which the response will be decoded. And one more thing is that I have overridden few of these fields on the original deployment using the configurations that are provided in the application struct. You can basically configure everything, but I have just for now configured the image name and the port over here. The container port I have used, I think I should use container port here. Yeah. The port I will use in service. So let's now create a service. Okay, so now finally we will actually create the deployment. We already have the code for that in the deployment file. So here, if I go into the create method, here we use the REST interface, which is the client, the client which implements it. So here the dot post is called over here. So I'll just copy paste this. Okay, so I'll just copy this over here. One small change, that this will be a new thing, and this result is the result deployment. Okay, now, and if error is nil, okay, so here we do this. Now let's make some changes on the original file, on the example file, and actually try to use this create method and see what happens. Okay, for now, let's just only create the deployment and let's just try to use it. So if I go back to my main.go, I'm using the same apps v1 and the same group, the same client set, but this time on my applications, on the default namespace, I'm calling the create function, and with these particular configuration. I expect that this will create a deployment. Okay, for now I'm not creating the service. I just want to see whether the deployment will be created. Let's see. Let's see. Let's see. Let's see. Okay, it did not give me any error. It did not panic. Let's just check. It created a deployment. Yay! Now let's just complete the function. Okay, so I just made few more changes here. So after a successful deployment is created, I'll now create a service, and with the default configuration plus this things that we overridden here. And if everything is successful, I will return this applications object. And in this applications object, few of these things are coming from the service, few of these things are coming from the deployment. Now let's call the function again, and but this time let's also check the result. Okay, so now I'll just added a log here that I just created an application, and this is the application. And let's just see what happens now. So if I run go run main.go, and if everything is successful, if my deployment and service is created, no, the server could not find the requested resource. What? What do you mean the server could not find the requested resource? The plot thickens. So the deployment is successfully created, but not the service. I wonder why. I wonder why the service was not successfully created. So at this point in time, what I want you to do, if you're following along, is to not go forward and pause the video and think a little that in create method, if this is successful, if I was able to call the post for this particular deployments resource and it was successful, why is the Kubernetes API server saying that services is not found? Services is in Kubernetes. So pause the video. I'll wait. Before I tell you the solution for this, this is kind of an exercise. Think about it for a while. Maybe you open the source code yourself and browse through the source code, use all the information that I just told you up until now, and figure out why was I able to create the deployments and not services. Go ahead. I will wait. Okay, so if you have followed along, the first thing that you would do to debug, because you now know the internals, that there is this do method that is called, and in the transform response, you have the whole request and response. So nothing is black box now. Okay, nothing is black box. So what you do is I'll try to log the URI where the request is actually being sent when I'm trying to create the service, right? So let's just try to do that. I'll just delete the deployment which was created, and I'll run the main.go again. And now I will get an error, of course, but here, okay, here's the URI. It says API/app/v1/namespace/deployment, which is correct. And then API/app/v1/namespace/default/services. Okay, so if I just do kubectl get services and I try to find out where the request goes, if you want to get the services, the URI is API v1 namespaces default, but here it is API apps v1 namespaces default. Have you figured it out right now why the URI in my changed code is wrong and why the URI here is correct? There's another hint. Okay, go ahead. I'll wait. Why the URI is wrong? Why the fuck is the URI wrong? Okay, I'm using the same exact REST interface, right? Okay, I'll tell you. Okay, so here's the juice. So each of these groups have this particular new for config method, which takes a particular REST config, and in this REST config just has host and API path and things like these. And this also contains like all the username, password, or in case you're doing OAuth, some token, or basically the credentials that will be required to talk to Kubernetes API server. This takes all of this config and combines this config into this particular REST client. And for each of these apps, for each of these groups, actually this is different. The way this particular REST client is created is different, so the defaults are different. So in this case, the API path would be /APIs, and then there would be group version, and this is set over here. So for the apps group, for the apps group, for the apps v1 group, the client that was created has the API had the path as /APIs/ the group version, which was apps in that case, but services is not in apps. What that means is that this particular client that exists here in the application, this particular client that exists here in the application struct, this client is given to this by its group, by its parent group, which is apps v1, which means that you can only do stuff on apps v1, because what this particular applications struct will do is that it will just append its own like resource name at the end of the URI that is provided by its group, and group has its own URI. So which means that you can use this particular client to only perform CRUD on the resources that is in the parent group. So you can do things on its sibling, but not on the cousin, or you get my point. Like services is not the brother of application, because application and deployment are both under apps v1. The service is not. So you cannot use this client. What can I do? So maybe there is a better method, but I'm going to do something really horrendous right now. Okay, so this is the monstrosity that I'm talking about. For deployments, I'm just going to directly call post and get on the REST client that was provided to us by the group. For services, I have to go one abstraction higher, which means that I will go and beg to my neighbor. But so because my own parent does not give me the client to talk to services, I don't have the lower level abstraction. So I'll go for the higher level abstraction, which means that I will go to the sibling of my parent, which means I'll go to my uncle. And in this case, my uncle is basically v1, is the core v1 group. So in apps v1 you have the deployment, and core v1 is the brother of apps v1, and in core v1 you have the services. So it means that now I got the deployment from my own parent, but for the for services, what I'll do is I'll just use the client that is provided by core v1. And the way I'm going to do that is basically I just change the function signature. So the applications now not only take the namespace, but it also takes the REST config, and I'm going to call that new for config function that I just showed you previously, and I will call that on my uncle, or basically in other words the core v1 group. I will get the core client, so which is a higher abstraction from just the post and put. So I'll just get that abstraction, I'll just get that core client directly from there, and just call the dot services like I would have done as an end client. So you can see that right now I'm doing this inside of the library, but usually this is done by the client, by the end, someone who is using client-go. So it's in a very weird way I'm just using client-go inside of client-go. I mean, these groups and these resources are created in a very independent way, but now I'm like in a very weird way tying them back together. And yeah, so that's why you should not do this. That's why you should not do this. But I'm just playing around with the code, right? So let me now call go run main.go again. First, let me delete anything if the previous demo deployment and demo services. And okay, I'm in the wrong. Let me go back to client go test and just run the go run main.go. Let's see what happens. Not enough arguments to call. Okay. So I did not pass the. Let me go back to the main.go and just fix it. Very small thing over here. So I just pass the namespace, but I also have to pass the config. So that is what I will do here, because I need the config. Basically this is what like here we created the client set by the config, but I again want the config because I need a new client just so that I can create a service. Now, as we have all that under our belt, let's do go run main.go, and if everything goes right, which it doesn't because there is a panic, an empty namespace may not be set. Did I set an empty namespace? Where did I set an empty namespace? Okay guys, I have made a severe and continuous lapse in my judgment. I have created two variables here, namespace and ns, and that's why there was a confusion. And I'll just remove the ns here and just add the namespace. And actually I don't even know why I have made those public. Those should be private, but we are writing bad code here right now. Okay, this is just a bad code. Any future employer of mine should not judge me by this code. This is just we're just playing here, right? We're just playing here. We're just playing here. Okay, Okay, finally, it should work now. It should work now. It should work now. Okay, okay, go run main.go. Let's go. Let's go. Let's go. Yeah, oh fuck. I forgot to delete it. Okay, I forgot to delete it. I forgot that the error came from service. The deployment actually got created. So let me run last time. Okay, last time. Go run main.go and what? Okay, guys, I have again made a severe and continuous lapse on my judgment. I have to, like seize the instance which is not filled yet. I'm actually passing the application over here. So the port value and the container port value is in this application that is passed as an argument, not at the original instance. So hopefully this should work now. Hopefully this should work now. Okay. Hopefully this should work now. Oh shit, I forgot to delete the deployment. Yeah, now. Container port, created application. Okay, created. Finally, we have an application. We have name, namespace, image name, container port, and this client and core CLI. This was the interface, and this is nil. So okay, so this was just addresses to the client and the address to the core CLI. Huh. And in that struct that we have, the other struct that is returned here, we did not fill these values, so that's why it's nil. Now, if I do k get deployments, I should see the deployment. There it is. If I do k get service, I should see my service. There it is. So oh, okay. Let me also, just to confirm that my application was created. Let me just do a demo deployment. Let me just port forward it, right? Oh shit. Yeah, let me just port forward the port 80. Okay, and let's just open in another terminal. Let's just try to curl it. Let's just try to curl it. Empty reply from the server. What the fuck you mean empty reply from the server? Connection refused. Okay, guess why this 8080 connection is refused? Guess why? Guess why? The reason is because I'm running an engine export. Engine export is not listening on 8080. The target port should be 80 and I made it 8080. So yeah, so the container port here should be 80. I just have to make it 80. Okay. Okay, now once more. Once more. I hope this time the pod comes up. The demo has ended at this point. The demo has ended at this point. Yay! We got a response from Nginx, and we deployed an application which was our own resource, which internally creates a deployment and a service. Usually in Kubernetes you have a client which saves, so like you can't have this in production because in Kubernetes this is not stored in etcd, right? There is no such thing as application that is stored in etcd. So so this is more like kind of automation for the client side. So instead of having a bash script which deploys the deployment and service individually, you can just do that in your own client go forth. Although why not just use that like kubectl, and just writing a script would be easier. But the whole point there was to just go through the source code and to make some changes to it. We did make some changes to it, and there is a lot to unpack here, like shared informers and indexers and what are all those, and they are in tool/cache. So the next series is going to be in tool/cache, and actually the whole, and after that we'll go to the API machinery and API, and it will take like months to just cover Kubernetes source code by source code if I keep making these videos. I think live would be a lot more easier to do because I don't have to like edit anything. I just can, raw dog the whole source code. I can just go from here to there, and I have to not worry about putting things together into a narrative, into a structured narrative. But the first series I did, I thought I should do it like this. So that was it for the video. And if you made it this far, I I don't know what to do now. I'll just I hope I see you in the next one, I guess. That's what they say. That's what they say when the video ends. I'll see you on the next one. Bye.
It's like the last time I'm over. Gotta be his willing. Vi får. कोई माउंट की चीज बनना जब तुम्हें को नीचा दिखाती रे पूरा दिन भर I'm just curious like beach how the fuck does the fuck know we mentally ill है but differently insurance नहीं रे मेरे तेरे